Hey everyone, I hope you're well. It's JD here, and today we're here with part 2 on showing you how you can set up your Unity catalog environment through Terraform. That's right, so if you remember in part 1, I showed you exactly how you can configure your Terraform workspace locally in order to authenticate and deploy a simple Metastore within your Databricks account. Well, here in part 2, I'm going to be showing you how you can take things to the next level. I'm going to be showing you how you can leverage Azure verified modules to deploy our Databricks workspace and our data lake storage account, which will then in turn help us deploy those services that we're going to need for our Unity catalog environment. So I'm going to be showing you how we can deploy our external locations, our credentials, and the catalogs themselves. And obviously, most importantly, I'm going to be showing you how you can assign your workspaces to the Metastores all through Terraform. If you missed part 1, I do encourage you to go and watch that, as that lays out the foundations that are required in order for this next part. But without no further ado, let's get straight into it. If you remember in part 1, I showed you how we can structure our Terraform workspace locally within our Visual Studio Code window, showing how we can leverage modules to make our templates reusable, and showing you how we can set up individual modules for each of the different components that we're going to be deploying. i.e., so we'll have a different module for our Unity catalog, our external location, our Metastore, and our Metastore assignments, for example. And then within our deploy.terraform, we call those modules and we execute the code and deploy that to our target destination. So in the example of the Metastore, we have a simple Metastore module here, and our source is pointing to our local workspace here in our UC_Metastore folder. And on the left are the parameters that we defined in that module, and on the right are the values that we're providing to those parameters. So as you can see, we need to provide a name, a region, a Databricks account ID for that module, and so we pass in values using modules. So that means we can make our infrastructure as code a lot more reusable. So as I mentioned in the intro, we're going to be deploying an Azure Databricks workspace and a storage account, which obviously need to reside in a resource group. So we're going to be leveraging Azure Verified Modules, or AVM, to deploy these resources. Now, if you don't know what Azure Verified Modules are, I suggest you go ahead and look them up, because they're really great. But in the short term, Azure Verified Modules are a suite of infrastructure as code templates that can be utilized and consumed by anyone. They're designed and developed by Microsoft and people in the community, designing infrastructure as code templates aligned to best practice. Okay, so these infrastructure as code templates by default are designed and benchmark against a well-architected framework and ensure that we have consistency when rolling out our infrastructure as code. Like I said, AVM is a whole nother beast in itself, so I don't want to go into the depths of that now, but I'm going to be showing you how you can leverage those templates. So as I showed you, we have a source here, and as you can see that this source is not pointing to a local template within my workspace. This is pointing to a remote repository. So with Azure Verified Modules, I'm going to be contacting that public registry in order to go ahead and download that template and deploy my Azure resource group. As always, I need to provide a location and a name for my resource group, and that's what I'm doing here. Similarly with the storage account, so I'm declaring my storage account module, and through AVM, I'm contacting the storage account template within the registry and passing in the specific configurations and parameters that are required in order for me to deploy that. So as you can see, I'm setting that I want my public network access to be enabled. I'm not using private endpoints in this case, etc., etc. And I'm also specifying the resource group and the location that that storage account is going to be deployed into. On top of that, I can then deploy the specific containers that I want for my storage account. So I'm specifying that I want a container called Data Lake and I want one called Unity Catalog, and setting those access types to private. On top of that, I can then assign role assignments to my storage account. So at the point of creation, what I'm doing here is that I'm saying I want to assign the Databricks Workspace Access Connector, the Storage Blob Data Contributor role, to my storage account. And I'll come on to exactly what the Unity Catalog Access Connector is as we'll cover that off now. So once we've got our storage account, we want to deploy our Databricks Workspace. Again, following that same pattern, I'm using the Azure Verified Modules registry and contacting the Databricks Workspace template within that registry. Setting my version, providing a name, setting a SKU as well for my Databricks Workspace. So I'm setting a premium SKU, and as always, I need to provide a resource group name and a location. Now, also, which is quite nice with the development of the Databricks template within Azure Verified Modules, is you have the ability to deploy an access connector. What is an access connector? Well, the access connector is effectively a managed identity that Databricks can use in order to authenticate against a against a data lake storage account. So if you think about in its nature, Databricks doesn't natively have a managed identity or a system assigned managed identity as part of its feature. But with leveraging the access connector, we get that same or similar functionality when it comes to authenticating against our data lake storage account. So this now means that we don't need to worry about setting up service principals and getting secrets and storing them in Key Vault in order to authenticate. We can do this all with the access connector, but we'll cover that as part of our deployment. And then once our workspace has been deployed, we want to assign that to our Metastore. So leveraging the Databricks provider within Terraform, we can assign that workspace to the Metastore. Now, if I show you the template for that, so if you go to our UC_Metastore assignment, we can see that we're using the provider, the Databricks Metastore assignment main, and we're providing a workspace ID and a Metastore ID. That is all we need to provide, because we need to tell the deployment what is the workspace ID that you want to assign to the Metastore, and to which Metastore do you want to assign this to. Once you have those two bits of information, you can create the relationship and the workspace can be assigned to the Metastore. Now, when it comes to obtaining those values, we're leveraging outputs from the modules. So if we take the workspace ID, which is the unique numeric number that gets generated for every Databricks workspace, we're referencing the output of our Databricks workspace module. So you can see we're saying module.avmres Databricks workspace .Databricks workspace _ID. So we're outputting the Databricks workspace ID and getting that value. And the same for the Metastore ID. We're obtaining the Metastore ID as an output of our Metastore deployment. So if we go to our Metastore module and we go to outputs, we can see here that we're outputting the ID and we're passing that in to our subsequent module. Brilliant. So now that we've got our configuration all set, what we can go ahead and do is we can go ahead and initialize our Terraform with a Terraform init. We can run a Terraform plan. This is all brand new, so I'm sure it'll be fine. 15 to plan. Now I'm going to do a Terraform apply. Proof. And that's going to go ahead and deploy. Now, once that is deploying, what I'm going to go ahead and do is bring in my other modules that I want to deploy into those services. Okay, so I'm going to be talking about my catalogs themselves, my external locations, my credentials, etc. So I've got these stored in a file here. I'm going to bring these over into my module here. Oops. Command C. Yeah. There we go. Got it this time. So here, what we've got is our external credential. So this is all about our Databricks Workspace Access Connector. How we're going to associate our Access Connector with our Unity Catalog Databricks Workspace environment. We've got our external location. So how are we going to authenticate against that data lake storage that we've got? So we're going to be providing our storage account ID as well as our credential ID, which is associated with that Databricks access connector that we defined up here. And then we've got our catalog ourselves. Now, as you will notice, that I've got different providers here to what I had for my workspace. So you can see that I've got a Databricks workspace provider and not using the Databricks.accounts provider. Now, if we navigate to our providers file here, you can see that I've distinctly defined two different providers for my Databricks. So I've got a provider specifically for accounts. So this is when we're deploying at the account level. So for all account level activities, we'll supply our Databricks account provider, but for any workspace level activities such as catalogs, external locations, credentials, we will supply the workspace provider. Now, as you can see, the main difference between these two is that the accounts provider provides the account ID, whereas the workspace provider provides the URL of the workspace. So as you can see here, leveraging the outputs from the AVM, we're outputting the workspace URL and providing that within our Databricks workspace provider. And that allows us to be more dynamic within our deployment. So while that is deploying, I will go ahead and just show you the new modules that we've added and talk about their configurations a little bit more. So as I started with the UC credential, as you can see, this is again pointing to my local repository, or my local workspace, I should say, not repository. And we've got one called UC_storage credential here. And again, all we're doing is using the storage credential provider. And what we're doing here is we're providing the ID for the workspace, for the Databricks access connector. Okay, so when we specify the provider, it knows what workspace to deploy that into. So all we need to do is go and provide that access connector ID. And what we're doing here is we're leveraging the output from our AVM module of that workspace connector. So as you can see, access connector IDs, connect, where's it getting connect from? Or connect is the one that we defined up here. And then we've got our external location as well. So what we're doing here is we're providing the location of our and the properties of our Data Lake storage account. So Unity Catalog has that ability to write to that storage account. So if we go to our external location, you can see here that what we're doing is we're providing the Data Lake container name where we want to store that data and the Data Lake name itself, okay, as well as the credential name, which becomes the credential ID. Okay, so we're providing the storage account details and then we're saying which credential to authenticate with. And that's exactly what we're doing here. Simples. And as importantly, we're specifying the Databricks workspace provider, not the account level provider. And then we define our catalog itself. Okay, so we give our catalog a name, we specify the storage account for that catalog, and then we specify the account ID as well, because we've defined that within our module. And then again, most importantly, we specify the provider for our Databricks, for our Unity catalog environment. Okay, so we're specifying this at the workspace level. So let's navigate back to Azure. As you can see now, those 15 resources has been successfully added. So if we navigate to our subscription and if we refresh that, we can see now that we've got our Unity Catalog resource group, which resides and hosts our Databricks workspace here and our storage account. So if we click on this and we click here, we can see we've got our containers. And you can see here as well, if I launch my workspace, if I log in, we can also access our Databricks workspace. Pretty cool, huh? So now that I've added that extra configuration to my Terraform, what I want to go ahead and do is I want to go ahead and deploy that. So I want to go ahead and deploy my catalog, my external location, and my storage credential. So I want to do a Terraform init again. And I'm going to go straight for a Terraform apply. while that's deploying. Just give that a couple of minutes. And that's now almost there. Excellent. So now that apply has completed. So now if I navigate back over to my Databricks workspace, and if I go to catalog, I can see now that my catalog is there, my dev-catalog. If I go to external locations, we can see that we've got our external location here now. If we go to storage credentials, we can see that we've got our storage credential. So all of this has now been dynamically defined through our Terraform. So what I'm going to do now is also show you in our accounts. If I go to my catalog and I've got my Unity catalog here, and if I go to Workspaces, I can also see that my workspace is part of that Metastore. Now, to validate everything that I've done, what I want to do is I want to upload a simple CSV into my storage account. So if I go to my storage account, and I go to Data Lake, and I go to upload, and what I'm going to do is I'm going to find my file, going to upload that here, and I've got my upload username.csv here. I'm going to create a simple cluster. You can do this all through Terraform as well, but for the purpose of this demo, I'm going to keep it simple. I'm going to keep that a single user cluster, and I'm going to hit create compute. I'm going to give that a few minutes to go ahead and deploy. While that's doing that, I'm going to go and create my simple notebook to go ahead and read my CSV file once my cluster has been created. Cool. So what I'm going to do is I'm going to trigger that. So while we wait for that cluster to start, now that my cluster is now spun up, what I can do is I can go and execute this simple command that will simply just go and read that CSV file that I uploaded into the storage account. I run that, and we can see that the CSV file has been successfully read under the context of that access connector connected to that storage account. So we've come to the end of the video, and as promised, I've shown you how you can automate the deployment of your Unity catalog objects through Terraform. Of course, you can push this through CI/CD pipelines and take this through that proper DevOps process where you have all that governance and all those guardrails in place to maintain the deployment of your Unity catalog environment. But I hope you found this useful and that it helps you accelerate your automation journey with Terraform and deploying Unity catalog objects. As always, if you can like and subscribe, I'll be posting the code to my demo in my GitHub repository, and the links will be provided down below.